And here we are again, continuing with the wrapping functions, but we're getting into the circle functions now. The circle functions are quite interesting, in my opinion. This is we're going to derive how to wrap a unit circle. So I have a unit circle here, and let me slide this guy over a little bit there, see if we can get her centered. Okay, and I put some crosshairs on. I put the x and y axes. This is the origin here. Give us a point of reference. All right, and with the unit circle, I mean it's tough to find every value and stuff, but let's think about a couple things we know about unit circle and wrapping functions. Wrapping functions deal with perimeter. All right, so we're talking perimeter. Now circles don't have perimeter per se. When you get to a circle, they now have a circumference. Okay, so circumference, we know a little about circumference, right? Circumference is equal to 2 pi r. Now, this circle doesn't have anything labeled, but you've heard me say the words unit circle before. And a unit implies it has a radius of 1. Radius equals 1. So the circumference of our circle is 2 pi times 1, or 2 pi. So that means from start to finish, the circumference is 2 pi. The distance traveled is 2 pi. So if this is a unit circle, we have 4 coordinates already. We have 1 comma 0, and we have negative 1 comma 0. And likewise, we have 0 comma 1 and 0 comma negative 1. So if I ask for a wrap, let's say, of pi, well, pi is half the distance, so a wrap of pi would go halfway around the circle. Right? So a wrap of pi would equal negative 1, 0. A wrap of 2 pi would be an entire trip around the circle, put us back at 1, 0. Think about what that means. If 2 pi takes us all the way around the circle, that's also considered our what? Yes, nice job. That's exactly what it is. That's our period. Good work there. So 2 pi is our period in a circle of radius 1. All right, so what would a wrap of pi over 2 be? Well, a wrap of pi is half the circle, and a wrap of half pi would be half of that. So we're at 0, 1. And how about a wrap of 3 pi over 2? Well, that's 1.5 pi. Well, here's 1 pi and a half a pi. 0, negative 1. All right, well, those are kind of easy, right? They're set on the axes. They're what we call quadrantal angles. They're what we call quadrantal angles. They're angles or wraps that fall, and we'll talk more about angles, but they're wraps that fall directly on an axis, an x or a y axis. They're on the quadrants. They're not in quadrant 1, they're not in quadrant 2, 3, or 4. They're between the quadrants. Okay, so they are quadrantal. Make sure you jot that down here for those who are trying to figure out how to spell quadrantal. Quadrantal. Maybe it's LE. No, I'm just kidding. It's that. Quadrantal. Okay, it falls directly on an axis, x or y, does not matter which. All right, so that's pretty easy. The pi's and the pi over 2's and the 3 pi over 2's and the 2 pi's and 4 pi's and 6 pi's and 8 pi's. And of course, in negative directions, the same thing. But what happens now if you're asked for a wrap of pi over 6, or a wrap of pi over 3, or a wrap of pi over 4? Those are all interesting questions to think about. Okay, and we're going to jump to the next page for them. So let's pull up another circle here. There we go, and I'm going to kind of ignore the axes, at least for the time being, and just kind of draw what I need in here. Here we'll call that the center. And you know what? I'm going to go and put some axes in here while we're at it. See if I can hit that. Boom! That's a nice shot right there. How about this one here? Well, not too bad. Might argue that my line's at a better spot than the dot, but the dot's there, so we'll move the line where it needs to go. All right, so we questioned a wrap of pi over 6 first. So pi over 6. Well, if this is a rep of 0, and this is a rep of pi over 2, and this is a rep of pi, and they have their respective coordinates, -1, 0, 0, 1, 1, 0. Okay, pi over 6, it would stand to reason, would be 1/6 of this, or 1/3 of this. So can I split a one quadrant into thirds? I mean, I can. Let's see if I can do it. So it looks like they're in thirds. All right, so that's kind of close. We can probably make this one a little better here. Let's bring him up there a little more. All right, that's a little bit better now. See, this is me being a perfectionist. Let's do that. There, now they're all about the same. Let's put the congruence marks here. There, not drawn to scale. All right, so this I'm saying is a distance of pi over 6. That arc length is pi over 6, right? I took pi over 2, right? This arc length right here was pi over 2. This portion of the circumference was pi over 2. I cut into thirds, which means 1/3 of pi over 2 is pi over 6. My question is, what is that coordinate right there? Well, fortunately, you guys are all experts at geometry, and we can drop a triangle, a perpendicular down to form a right triangle. We know we're in a circle of radius 1. So I'm going to label this, which is my radius, right, from the center to the edge, as a distance of 1. Now this is where a little intuition comes in. A rep of pi over 6, I have 1/3 of this quadrant. Well, 1/3 of this quadrant, isn't this a 90-degree angle, right? The quadrants are 90 degrees each. 1/3 of that means this is 30 degrees. If this is 30 and that's 90, this is 60. That means I have a 30, 60, 90 special right triangle. Probably were wondering all these years after geometry what was so special about 30, 60, 90s. Well, now you know. They're the basis of the unit circle, which is the basis of all trigonometry. Okay, so our 30, 60, 90 special right triangle. For those of you who don't remember the 30, 60, 90, I'm going to do a quick derivation for you of what that tells us, per se. See if I can get another 30-degree angle right here. Okay, so basically I'm taking this triangle and I'm reflecting it over the x-axis. So that's 30, this is 90, and this is 60. Well, this is a radius, so that's got to be 1. And this is now a 60, 60, 60 equilateral triangle. Equilateral, by definition, means all sides are the same. If this is 1 and that's 1, this whole thing here has to be 1. Okay? And again, by definition, this axis I have here is bisecting the triangle. When you bisect an equilateral, you cut it in half. Well, if this whole thing is 1 and I cut it in half, that means this is 1/2, as is this. Well, this is the vertical component. I already have my y-coordinate, 1/2. And with a little bit of math, Pythagorean theorem that is, I can figure out the x component right here. I'll call this distance right here x, and that goes from the center all the way to here. So we're looking for that distance x right there. All right, so a squared, well in this case c squared, equals a squared plus x squared. So 1 equals 1/4 plus x squared. So x squared equals 3/4. So the square root of 3 over the square root of 4 equals x, which means x equals the square root of 3 over 2. Root 3 over 2. So I've now found a rep of pi over 6. That is a rep of pi over 6 for us. Let's move on to a different rep, and let's do a rep of pi over 3. Again, we'll create a separate circle for this one. So here's our circle. Center this guy. And let's again put some axes in here right off the bat this time. Ooh, that one's way off. Should have put my dot there. That one's pretty good though. So let's see what we can do about this guy. And again, we're going to do a wrap of pi over 3. So if this whole thing, remember, the wrap of pi, right, the distance around half a circle, the circumference of half a circle, half a unit circle is pi. I'm going to split this thing into thirds. So I'm kind of ignoring the y-axis there as I'm trying to split this into thirds. Oh, that's curving there a little bit. Trying to split this guy into thirds. So now this piece and this piece and this piece are the same. Okay, so now we've created 3 equal pieces here. So if this is pi, each piece is pi over 3. It's 1/3 of that. So this distance that we're talking about right here, the distance around this arc, little swoosh sound, is pi over 3. So that's what we refer to as a wrap of pi over 3. So our goal now is to find the coordinate. Well, we know, much like each quadrant is 90 degrees, we know each half of a circle, semicircle, is 180 degrees. Well, if I'm splitting it into 180 degrees into 3 equal sections, each one is 60 degrees. And again, we can, being experts at geometry, drop this down as a perpendicular and create a triangle, a right triangle, in which case I again have a 30, 60, 90 special right triangle. We know the radius is 1, and we just did a 30, 60, 90 on the last page, right? So if I pretend this is the same as the last one, the side opposite the 30-degree angle, let's take a closer look, the side opposite the 30-degree angle is half of the hypotenuse. So opposite the 30-degree angle is 1/2 the hypotenuse. That's this piece right there. So my x-coordinate is 1/2. And the Pythagorean theorem, again, will tell us that this component, in other words, the piece opposite the 60-degree angle, is square root of 3 times the short leg. So root 3 over 2. And we got a new coordinate. All right, I'm going to stay on the same page here, and we're going to look at just the third quadrant here. And we're going to split the third quadrant in half. Well, if this is 90 degrees, that means if I split it in half, this guy is 45 degrees. All right, 45 degrees. I'm going to try to find my coordinates here. Well, this is 45 degrees, which means this is a special 45, 45, 90 triangle. In other words, it's isosceles. Isosceles, by definition, has 2 legs that are the same. So Pythagorean theorem says that a squared plus a squared equals 1 squared, well, the hypotenuse squared, which is 1. So 2a squared equals 1, which means a squared equals 1/2, which means a equals the square root of 1 over the square root of 2, which means I'm going to rationalize. The square root of 1 is 1. 1 times the square root of 2 is the square root of 2. And the square root of 2 times the square root of 2 is 2. So I get root 2 over 2. So my coordinates, because I'm in the third quadrant, are negative root 2 over 2 and negative root 2 over 2. If I was in the second quadrant, that would be x is negative and y would be positive. If I was in the fourth quadrant, x would be positive and y would be negative. If I was in the first quadrant, they would both be positive. So, if this is pi over 2, half would be pi over 4. Right? So this would be a wrap of pi over 4. If I'm in the second quadrant, well, pi over 4 is this distance, which means this distance is also pi over 4. So I'm pi over 4 away from pi, which means I'm at 3 pi over 4. Here, I'm pi over 4 beyond pi. That's 5 pi over 4. And here I'm pi over 4 away from a full trip, right? This was 2 pi once you went all the way around, correct? It was 0 and 2 pi. 0 to start, 2 pi if you go all the way around. I missed going all the way around by pi over 4. So that's 7 pi over 4, or 1 3/4, right? We're always going to use the fraction zone in this case. Wrap of 7 pi over 4. So there's the derivation of the unit circle for you. Hope you followed it. Don't worry, we'll pick up more of this in class.